In this video we are going to continue the discussion of K-maps, right? So in this session we will see how to solve the problems related to K-map. Now here we have a problem. We have to minimize the POS expression, we have to use the K-map, and we have to write the result in the POS form. But in the K-map we have minterms given. Now we should solve and give the result in POS form, that is in max terms. Okay, now since we have minterms given, we will write down the max terms in the remaining positions, that is we will get zeros here, 0 0 and 0 0 0 0 0. So like this we can form, and now we can group them. So this is one group, followed by this four corners is another group. So these are the possible groups which I can form. Now using these groups I can write the answer in POS form, that is f, which is equal to this group. You can write it here: y bar, z bar, y bar, z, y z, y z bar. So it is in SOP form, or what you can do is you can write in POS form: y plus z, y plus z bar, y bar plus z bar, y bar plus z, and here also w bar plus x bar, sorry, 0 we have w plus x, and w plus x bar, w bar plus x bar, and here w bar plus. So finally what we can do, we can write the expression f, which is equal to, here we can take common, what we can take w bar common, and here we can take y. Okay, so w bar plus y, w bar plus y into, and here all the corners we can take x, and we can take z, x plus z. So this is the final solution we have, f which is equal to w bar plus y into x plus z. So this is how we can solve a given K-map in the POS expression. And if the answer should be in SOP form, we are going to group ones, that is minterms, and since it is given the answer should be in the POS form, we are grouping zeros. Now we have to minimize this particular expression phi m with 0 4 5 8 9 11 plus don't care 2 comma 10. Now it is a 4 variable, so we should draw the 4 variable K-map. So total number of cells 2 power 4 will be equal to 16, and there, since it is pi m, so pi m represents POS expression, POS form. So these are all our max terms. So these are all our max terms. Now how to draw the K-map for 4 variable? We will draw like this. This is 0 1 3 2 4 5 7 6 8 9 11 10 and 12 13 15 14. Okay, so we should write max terms, that is 0 4 5 8 and 9 and 11, followed by don't cares 2 and 10. So these are our don't cares. Okay, now so we were discussing the minimization techniques of K-maps, and so they have given a Boolean. I hope my screen is visible, right?
Oh, yes.
Yeah. So they have given a expression in the POS representation pi m 0 4 5 8 9 11 plus don't cares 2 comma 10. So this is a continuation for the previous sessions where we have started with the key maps, and this is a continuation session. So if you haven't watched them, please rewatch the recordings. Okay, so I'm writing the wx yz and y plus z. So it is 0 0 0 1 1 0 1 1, like this you can map. So it is y plus z bar, y bar plus z, and sorry, 1 1 1 0, y bar plus z. Okay, and here also w plus x, w plus x bar, and here it is w bar plus x, w bar plus x bar. Okay, so like this you can form, and you can do the grouping, and you can write down the answer. So this is, and here if you have don't cares, you can group the don't cares. So it will be, wait a minute, let me change the color. So this will become one group. So if we have a don't care, we can group it with the max terms, and this all corners will also become one group. So like this you can form your groups, and this two will become another group. Okay, so like this you can group your max terms, and you can write down the expression which we have discussed in our first example. So you can say, you can take the reference of that first example, and you can form your group. Okay, now similarly we have expression f of wxyz, and here we have given minterms. Okay, so how to identify minterms, whether it is a minterms or max terms? How can we identify? Any idea? How to identify whether the given thing is a minterm or a max term? Any idea? So in our previous sessions also we have discussed this. So this symbol, if it is sigma, it is a minterm, small m representation, and if it is a pi followed by capital M, it is max term. Okay, now minterms corresponds to 1. So we will write down all the ones. So it is a 4 variable k map. So let me draw that k map. So for 4 variable, it will be total number of cells will be equal to 16 cells. 2 power 4, that is equal to 16 cells. 2, 3, 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Now I can fill all the cells. 1, 3, 5, 6, 7, 11, 14, 15. 7 and 11, 14, 15. Let me change the pen color. Now so we can let me check. 1 3 5 6, 1 3 5 6, 7 11, 7 11, 14, 15. Yeah, so here what we can do, here we can group all this 4, and here also we can form a 4 group, and here also we can form a group of 4. Okay, this one, and it is wx yz y bar z bar y bar z yz y z bar, w bar x bar, w bar x, wx, and wx bar. So you can write down the Boolean expression. It will be like here the common term is w bar into, and here the common term is z plus, and here the common term is yz, uh, yz plus, and followed by another common term is y followed by yx. So this is how you can solve a k-map, and you can solve the Boolean expression using the k-map. Okay, so is this clear up to here? Is there any doubt?
It's clear.
Yeah. Now we have given a logic circuit, and we have to find what is the redundant gate in this particular circuit. Can you able to do this? Will you try this? Please take your time and try this. We have to find uh, the redundant gate. That is the gate we don't want. So you can use a key map and you can find what is a redundant gate. So first write down the expression for x, and from that draw a key map. And we have already discussed what is meant by redundant terms, redundant implicant, everything, right? So from that you can find out which gate, which group you are getting a redundant implicant. Okay, so let me do it. So what is the expression for x, output x, which is nothing but the and of x y bar z, x y bar z plus w bar x z, w bar x z, and w bar y z plus w bar y z. So this is our output. What is the output expression we are getting? X w bar z plus w bar x z plus w bar y z. Now since it is a four variable k map, it is a four variable k map. So total number of cells 2 power 4, which is equal to 16 cells. So I will draw a k map. Okay, and here wx y z, y bar z bar, y bar z, yz, and yz bar, w bar x bar, w bar x, wx, and wx bar. So I should plot this particular expression on the schema. So how to plot this? X y bar z, where I am getting this particular pattern x. So I should find where I will get the common term x. So here I will get the common term x. So I can write one here, and I should get y bar z. So where I will get y bar z? Here I will get y bar z. So if I write once here, I will get this particular term x y bar z. Okay, since x is common here, so I will write 1 1, and y bar z. Okay, y bar z and x is common in these two cells. I will write minterms here. Is it clear how I am plotting this particular expression on my K-map? I think it is clear now. How to plot this w bar xz? So I should find what is where is w bar common. So here my w bar is common followed by xz. So here x is common and z is common here. So I will write my minterm here, w bar x z. I want z. So w bar, here it is common, w bar followed by xz and w bar yz. Okay, w bar x and I will get z here, these two terms, and here I will get w bar yz. Now I can group these two terms, minterms, and I can group these two minterms. Okay, now these two are essential prime implicants. About essential prime implicants we have discussed in our previous sessions. What is meant by essential prime implicants and what is meant by prime implicants. So these two are my essential prime implicants. Now if I group this bit, if I group this two, then it is a redundant prime implicant. This grouping is not necessary. It is a redundant prime implicant. So what is this grouping? Due to this grouping, watch which term is forming. This term w bar xz is being forming. So what is the redundant? What is the redundant gate we have? W bar xz where we are getting here. So this is a gate number 2 is a redundant gate. Okay, so we don't want this particular gate. So this is how we are going to solve if a, how to find a redundant gate. Okay, using the K-map. Is it clear or should I explain it once again? Yeah, I think it is clear now. So for the K-map shown below, the minimized function in SOP form, they are asking the minimized function in SOP form. So how to do this? Same, the grouping. So here we can group these 4 cells and all the corners we can group, and we can group this 2 cells. Okay, now what is the expression we have? This is y bar z bar, y bar z, yz, y z bar, and this is w bar x bar, w bar x, wx, and wx bar. Okay, so all the 4 corners what we have common x, this 2, right, and we have here w followed by y, wy plus w bar x bar into y bar, w bar x bar into y bar, and w bar x bar x bar, and here we have z bar plus x bar into z bar. So this is how we can uh, minimize a SOP form of expression. Okay, so yeah, so that's all for this session. So I think it is clear if you are given with a redundant term like don't care how to group them, and if you have given a logic circuit by using the K-map, how to minimize a Boolean expression, everything. I hope it is